of oscillations per second. Heart pumps the blood to the different body organs.
Both statements are in true, it is always true. A pleasant good afternoon to one and all. This is your lovely and sweetest friend M.Mani from Mahendrahills. Today is a marvelous and wonderful day ever in my life because I was selected as super student in physics. I really thank our Secretary Sir for introducing Mana TV Super Student Lecture in which we can teach a lesson. So I really feeling happy because I love teaching. So today you sparrows, you are going to learn one interesting lesson. Okay then, let's get into the lesson. Okay sparrows, for what sake we eat food? We eat food to get energy. Exactly. And I want to hold something. For example, I want to hold this chalk piece box. So for that, what I need energy. So from where we are getting that energy? Because we are eating food. So, do you know sparrows? There are also different types of energy. For example, food energy, electrical energy, water energy, mechanical energy, potential energy, kinetic energy and so on. So, these energies are very useful in our life. Okay friends, tell me what are the basic needs of a man? I'll tell you. Air is the basic need of a man, food and also shelter. Okay, without air we can't live, and without food it is also impossible for a man because there is no energy, and without shelter a man cannot live. Okay friends, there is also another basic need that a man use. It is nothing but without that city we cannot live. It's nothing but electricity. So today our topic is about electricity. Okay friends, now tell me, think that it's evening 5 or 6 o'clock. So that time what you will observe in the surroundings? We will observe that our surroundings are getting dark. Okay, we are the students, so we have to complete our homeworks, we have to eat, we have to chit chat with one another. So can we do anything in the darkness? No, it's impossible. So in the darkness, something is helping us to see or to do any work. Do you know what is that? You may have the guessing. Yes, it's nothing but light. Okay friends, now tell me how the light glows. What making the light to glow? Yes sparrows, it's nothing but electrons. It's nothing but electrons. So the flow of electron is known as current. The flow of electron is known as current. Electron is known as current. Okay, the flow of electrons is known as current. Okay sparrows, now tell me how the current flows, from where the current is coming to different areas. Yes, the current is coming from many power stations like hydel power station, thermal power station and many of the power stations. So how from power stations to different areas, how it's coming? Yes, it's coming due to potential difference. It's coming due to potential difference. And now you may have the doubt, what is potential difference? I'll tell you. Potential difference is nothing but the flow of charges from one end to other end of a conductor. The flow of charges from one end to other end of a conductor. Flow of charges from one end to conductor is known as potential difference. Okay, now Tswreis, tell me, do you know how the current flows? I'll tell you. I'll give you a simple example so that in future you may know how the current flows, because physics is the basics. So I'll tell you that. Do you know how the water flows? The water flows from higher level to lower level. How it flows? From higher level to lower level. Similarly, the current also flows from higher potential to lower potential. How it flowing? From higher potential to lower potential. Okay, so the current. Now tell me, depending upon the current and potential difference, one of the scientists named as George Simon Ohm had introduced one law. Okay, depending upon the relationship of current and potential difference, one of the scientists known as George Simon Ohm had introduced one law. It is also known as Ohm's law. Okay, it is also known as Ohm's law. So according to Ohm's law, what is said that the potential difference is directly proportional to the electric current at constant temperature. The potential difference is directly proportional to the electric current passing at constant temperature. Okay, so I is directly proportional to V. Okay, I is nothing but current, I is nothing but current, V is nothing but potential difference. At what? At constant temperature. Okay, here constant temperature is nothing but resistance. The constant temperature is nothing but resistance. Okay, so you may have the doubt, what is resistance? I'll give you one simple example. Okay, so think that we always love to drive. Okay, we always love to ride on a vehicle. So on the road, when we are driving on vehicle, there is one thing that is required to slow down the speed. Okay, what is that? Can you guess? I'll tell you. It's nothing but speed breaker. The speed breaker is used to slow down the speed of a vehicle. Similarly, the resistance is nothing but which opposes the flow of electrons, which opposes the flow of electrons. Resistance is nothing but which opposes the flow of electrons. Okay, here the potential difference, the flow of charge from one end to other end of the conductor. Okay, it is denoted by V. So see how the current is passing. I gave you the example that the water always flows from higher potential to lower potential, higher level to lower level. Similarly, the current also flows from higher potential to lower potential. See here, Ohm's law, the current is directly proportional to the potential difference at constant temperature. Okay, now see here. Now students, here I is directly proportional to V at constant temperature. Constant temperature is nothing but resistance. We know that resistance is nothing but which opposes the flow of electrons. Okay, I is equal to V by R. Because why here V by R? Because we are taking constant. So I is equal to V by R. Otherwise, we can also take as V is equal to IR. Okay. Okay. Sparrows, I will give you a simple example. It's like a magical triangle to remember the Ohm's law, because we have to study higher education. For that, this 10th class is basic, no? For that, Ohm's law is very important. So, I'll give you a simple magical triangle so that you can remember Ohm's law. Okay, Sparrows, see here, it is a triangle. Okay, it is a triangle. I am dividing this into 3 parts. Okay, did you follow me? It is V, it is I, and it is R. Okay, now if you want V, just close V. What we are getting? I into R. What we are getting? I into R. So, for example, you need I. That's nothing but current. So, for that, what you have to do? You just have to close I. What you will get? V by R. V by R. So, if you want resistance R, what you have to do? You just have to close R. That means what will happen? V by R. V by R. Okay. See here, if you want V, that you have to do I into R. If you want I, you have to close I. You will get V by R. And if you want R, just close R. You will get V by I. So, depending upon the Ohm's law, we have many connections. Okay. Okay, Sparrows, we have many connections. The first one is, I'll give you example that we have street lights, no? You all people have street lights in your house or in your schools. We have street light. So, if you want, you think that it's a 5 or 6 o'clock, you have to make the light to glow. So, that time you will go near each and every light and you will have to switch on the street light, is it? No, we will go to one of the main. There will be one main, and you have if you go there and if you once switch on the main, what will happen? Connection. See here, Sparrows, it is series connection of resistors. What we are saying, there is only one way for the path, there is only one way for the current to flow, there is only one way to for the current to flow. Here is this is the resistor, this is the resistor, this is the resistor. Okay, here it is some potential difference, here it is the some potential difference, here it is potential difference. Here what we have to observe that here the current is same. What is current is same, but the potential differences are different. The potential differences are different. That means V is equal to what we will get? All the potential. Here what we are saying, that sum of individual potential difference is equal to this, to all the potential difference across the resistors. That means V is equal to V1 plus V2 plus V3. What we get? V1 plus V2 plus V3. Okay. So, what we have learned that here in Ohm's law, what we have learned? Ohm's law, V is equal to IR. Is it? IR. So, for the resistance of first resistor, what is the V is equal to what will happen? V by R1. What will get? V by R1. Okay. V is so the potential difference of V1 is equal to what? V1 what will get? IR1. What will get? IR1. And next, what is the potential difference of V2? Difference of V2. What is IR2? IR2. Here current is same, no? If you once break out the if you once break out anyone, what will happen? All will stop glowing. Okay, the potential difference of V3 is equal to what we got? IR3. What? IR3. So we have to substitute this here. Okay. Then what we'll get? See here. V is nothing but IR is equal to V1. What is V1? V1 is nothing but IR1. IR1. Okay. Plus V2 what? IR2. What we are getting? IR2. Plus V3 is nothing but IR3. IR3. So if we take I as the same, because I is always I is same in the series connection. That means I is nothing but current is same in the series connection. That time what we will get? R. R is nothing but equivalent resistance. Equivalent resistance. So R1 plus R2 plus R3. Equivalent resistance is nothing but, here we are saying, if you take the sum of individual resistance is equal to the sum of individual potential difference is equal to the sum of across the potential difference. Okay. So what we got in series connection? Equivalent resistance is equal to R1 plus R2 plus R3. Here is an example. Okay, see here, I am switching on. What is going? The current is passing from here. There is only single path for the flow of current. It is known as closed circuit. Once I broke this, what happened? Here all stop glowing, is it? So if I once keep here, what happened? All are started glowing. That means it is known as closed circuit. What is known as? It is known as closed circuit. The current is same. The current is same, but the potential difference is different. Okay. So this is known as series connection. Okay, Tswreis. Okay. In series connection, what we have seen, the sum of individual resistance is equal to the equivalent resistance. The sum of individual resistance is equal to their equivalent resistance. So series connection, RT is nothing but the total resistance is equal to R1 plus R2 plus R3. R1 plus R2 plus R3. There is only one path for the flow of current. Okay. The next one. What is this? See here, there is the battery and the positive one and the negative one. There is only one way for the flow of current. This type of series connection we can see in decorating lights. Okay, we always celebrate Christmas, no? That time we have decorating lights. This is the example of series connection. These are very useful. It gives so much attraction to the homes. Okay, and here another example is there. What is that? That is the street light. I told you before that it is an example because one person cannot go to each and every light to switch on. So there will be one main for the flow of current to all the lights. Okay. And the next one is, okay friends, tell me that you are in home. You are in home. So what will happen? You are in a hall. You want to switch off the bedroom light. So that time we have to go near to the switch and we have to switch on the bedroom light. If we have series connection in our homes, what will happen? There will be light equal like whatever it is in bedroom, we will also have in hall, no? So it is waste of electricity. Is it right? We should not waste the electricity. So is it necessary series connection? There must be other connection, because we should not waste the light. So that time what connections are required? That time the parallel connection are required. What is required? The parallel connection are required. The next one is parallel connection. Okay, you see in here. See here. This is a parallel connection. See, the lights are inserted in such a way they are parallel to each other. They are parallel to each other. Okay. What we are saying here, the potential difference is same. See here, the potential difference is same, but the current is different. In parallel connection, the resistors are situated between two ends of a conductor. So here what we are saying, the current is not same to everything. Okay, for this one it is I1, and for R2 it is I2, for R3 it is I3. But when we see that the sum of these current is equal to the across the current. Okay, the sum of these current is equal to the sum of this. I will give you one example. For example, see here, there is one river. Okay, it's flowing. Here it is one way, here it is another way, and here it is another way. The water is flowing like this, here, here, here. So when we observe this, what will happen? If we combine this, what we'll get? We'll get this water, no? If we combine this water, this water, this water, what we'll get? This one. So similarly, in the parallel connection, what we'll see that I is equal to I1 plus I2 plus I3. What we got? I is equal to I1 plus I2 plus I3. Okay, sparrows. Here we are seeing. See here. Okay. Now see here. I switched on this. It is the current that is flowing. We have different resistors. Now I switched on this. What happened? The certain bulb only glowed. So this type of parallel connections we have in our homes. And I switched on this. What happened? This one only glowed. When I switched on this, this one only glowed. When I switch off this, it only stopped glowing. Is it this? They are glowing, no? So it stopped glowing. That means it have different current flow. Okay, see here. That means in Ohm's law what we have learned, that I is equal to what? V by R. Okay, so the current drawn by I is equal to what will happen? V by R1. Is it here? See, R1, R2 and R3. Next one, I is equal to, I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to what we got? V by R3. When we substitute this here, what we will get? I is nothing but V by R. I is nothing but V by R. So V by R is equal to, I1 is nothing but V by R1 plus V by R2 plus V by R3. Okay. So here the potential difference is equal now. So that means when we take this as the same, what we will get? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, did you got my point? Okay. So in parallel connection, what is the formula? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. See here, the parallel connection, all the resistors are connected in between two ends. I told you before only, no? See here, what is happening? All the resistors are connected in between two ends. All the resistors are connected in between two ends. Now, okay, the next one, see. So, according to parallel connection, what we have learned? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, see here, the connection. The first one is going to, it has certain current to flow only for the first bulb, and the second one is flowing. Did you observe that? The blue one is flowing only through the first bulb, and the red one is flowing only for the second. See here, there are three resistors. The battery is giving, the battery is there, and the current is flowing through the first one and the second one and the third one. Okay, they have different current. Okay, I have told you before that, see, the resistors, they have different switches. They have different switches. Okay, the next one. So, what we have observed here, that in parallel connection, the current are different. The potential difference is equal. So, for the first one, if we switch on the first one will be glow, and for the second one only go, and for the third one only glow. If we switch off the middle one certain will stop. The first one, third one. Okay, so this type of parallel connections are useful in our homes, and we will have in different areas. Okay, now tell me, what is Ohm's law? So, according to Ohm's law, okay friends, now we have learned what is current and what is potential difference, and also what is Ohm's law, and also what is series connection and parallel connection. Okay, according to Ohm's law, what we have learned? That we have learned that Ohm's law, what we have learned? That I is equal to V by R. What? I is equal to V by R. That means the current is directly proportional to the potential difference at constant temperature. The current is directly proportional to the potential difference at constant temperature. So, if you forgot Ohm's law, you can also remember one thing. What's that? It is a wire. Okay, it's a wire. The current is flowing. Okay, the current is flowing through here, I. So, the I always depends upon the potential difference, no? For example, I will tell you another. This is one tank. Okay, it's have till this level water, and there is another tank. It have till this. So, there is one pipe. So, we already learned that water always flows from higher level to lower level. Similarly, here what will happen? The water will flow through here. So, how which amount the water will stop flowing? Till it reaches equally. Till it reaches equally. Till here. Okay. Similarly, it starts. We have to remember this for the Ohm's law. That is, current is, for example, think that it is current. It flows from higher potential to lower potential. Okay. Hello. Who is this?
Hello, Maniswara. Hi.
Hi. How are you?
I'm fine. What about you?
Yeah, I'm fine. And who is this?
I'm Purna from Tswreis School, Hyderabad district.
Oh, Purna. How are you, Purna?
Fine.
Yes. Tell me.
My question is, what is meant by parallel connection?
Yeah. In parallel connection, okay, Purna, good question.